All right, so these are the keys, the key to the problems on some of the topics that we're covering in this course. So number 12, you want to solve this absolute value equation. Now, to solve an absolute value equation, what you want to do is isolate that absolute value expression by itself. So get the absolute value of 3x minus 5 on one side by itself. So then what I would want to do then, if I'm going to isolate this absolute value expression, see right now I'm subtracting 7, so then the opposite of subtracting 7 is to add 7 to both sides. So I'm going to go ahead and add 7 to both sides. What you do to one side, you do to the other. And then when I combine like terms, a negative 7 and a positive 7, that is 0. So those are opposites. So when you add two numbers that are opposites of each other, you get 0. And so I end up with this absolute value expression, the absolute value of 3x minus 5, that's absolute value bars, is equal to, and then 8 plus 7 is 15. All right, now when you get to that point, the next thing you want to do, remember that this is not a linear equation. So this is an absolute value equation. So when we talked about absolute value, the definition of absolute value, remember we looked at it in terms of a number line and the distance that a number is from 0. So when we talked about solving an absolute value equation, that's where we had to break this into two parts. So basically what she said was, well, one approach I can take is the absolute value of 3x minus 15 minus 5 is equal to 15. I can find the solution to that absolute value equation by first of all writing it as the 3x minus 5 equals 15, and then 3x minus 5 equals the opposite of 15. So remember, the absolute value definition that we discussed was the distance that a number is from 0. So I want to know what what values of x that I can substitute into the expression, take the absolute value of it, and that distance will be 15. And so you have from 0, you have 15 and negative 15. Alright, so then you just solve each of those linear equations. So you went from an absolute value equation to two linear equations, and you just solve for it. So we add 5 to both sides, and so I get 3x equal 15 plus 5 is 20. And then divide both sides by 3, you get x to be, and then reduce if you can, you get x to be 20 thirds. So that's one of your solutions. So if you went back to the original equation and you substituted 20 thirds, you would see that this left-hand side is equal to 8. And we can do that real quick just to show you. Um, so I'm going to do it here. Now, let me just say, so if you recognize that this is going to have a solution, you really, let me rephrase this. Notice that the absolute value of 3x minus 5 is equal to a number, right? And that number is positive. So you will have solutions. If there were variables on the other side, which you're going to see in a moment, if you had variables on both sides, you have to check. And because this is that would be a variable expression. This is a numerical expression. The absolute value of 3x minus 5 can be 15, and one of them is 20 thirds when you substitute for x. So watch. So if I check x equal 20 thirds, you'll see that it works, because you have the absolute value of 3x minus 5 minus 7 is equal to 8, right? So in place of x, I'm going to substitute 20 thirds. So I get the absolute value of 3 times 20 thirds minus 5, and then I'm going to subtract 7, and I want to see if that's going to equal 8. Well, 3 times 20 thirds, the 3's divide out, so 1 times 20 is 20. 20 minus 5 is 15. So I get the absolute value of 15 minus 7. Well, we know that the absolute value of 15 is 15, and then 15 minus 7 is indeed equal to 8. Okay? All right, and then we do the other one. So we're going to add 5 to both sides. And so I get, I'm just going to put that here, just in case you want to look at it again. So I'm going to add 5 to both sides. And when I do that, this is 0. So I get 3x equal a negative 15 plus 5 is a negative 10. And then to solve for x, I'm going to divide both sides by 3, since the coefficient of x is 3. 3 times x, the opposite of multiplication is division. And 3 divided by 3 is 1. 1 times x is x. So I get x to be a negative 10 thirds. And those are your two solutions. So you don't you need to look at your absolute value equation to determine if it's actually going to have a solution. So I noticed that the left hand side right here, I'm taking the absolute value of that 3x minus 5, so that can be 0 or positive. It can never be negative. So there is at least in this case there are two numbers, two values of x for which the left hand side will equal positive 15, and those are the two numbers. So that's it. So remember, you're going to get the absolute value expression by itself, then you're going to split it apart into two equations without the absolute value bars. So remember, without the absolute value bars. So 3x minus 5 equals 15, and then the opposite, negative 15, and you solve for x. All right, number 13, we had this. So this right here was an absolute value equation, and number 13, we have an absolute value inequality. Now, we talked about two types of absolute value inequalities, a less than and a greater than. So number 14, when we look at 14, we have a greater than. Those are solved two different ways. Now, when we solved the absolute value equation, I had a finite number of solutions. So in other words, the solutions was finite. I can count how many solutions there are. There are two, right? So the solutions are x equal 20 thirds and then negative 10 thirds. Those are the solutions. There are two of them. When we solved an absolute value inequality, we saw that in some cases you could have an infinite number of solutions. Sometimes there were no solution. We looked at a couple examples like that where there were no solutions. So there were either, in the ones that we looked at, either an infinite number of solutions or no solution. When you have a less than inequality, less than, there are two ways you can do this. All right, I'm going to do it the long way. That's going to be comparable to the greater than. And here's the other way. All right, so when solving an absolute value inequality with less than, this is what you're going to write. You're going to say 4x plus 3 is less than 8. And at the same time, so that's an and statement. Less than is an and statement. Less than is an and statement. Okay, less than and statement. So basically, you're going to rewrite this absolute value inequality without absolute value bars. So basically, you write what you see without the absolute value bars, and at the same time, 4x plus 3 has to be greater than negative 8. So notice less than, greater than, 8, opposite. Okay, less than, greater than, 8, opposite. The left-hand side expressions stay the same. Now, when you the other way, so that's one way you can write it. Now, when you write it this way, you have to make sure you put the word and, so you don't get any points taken away. All right, so you must use the word and. The other way is this way. You can write it. So we saw that we can write this in compact form, meaning this. So you can write it as, so this is number 13. You can write it as 4x plus 3 is less than 8, which is what this is. And remember, at the same time, this expression, see that? This expression must be greater than negative 8, meaning this. So this right here must be greater than negative 8. So you can write this absolute value less than either as an and statement, or you can write it as a compact form right here. So this right here means this. 4x plus 3 is less than 8, and at the same time, 4x plus 3 has to be greater than a negative 8. So this is this right here. So this expression, this inequality statement right here, is the same thing as this. So you have to recognize that this and this are the same thing. 4x plus 3 is greater than negative 8. Negative 8 is less than 4x plus 3. Or 4x plus 3 is greater than negative 8. They mean the same thing. Alright, but if you're going to write it as two separate ones, you have to put the word and. Don't leave the word and off. You won't get all your points. Alright, now, so we're going to come back and do both of those, but let's go to this one first. Alright, so you're going to solve each of those individual inequalities. So I'm going to subtract 3 from both sides. And when I combine like terms, 3 and negative 3 is 0, so I get 4x is less than 8, and a negative 3 is 5. Divide both sides by 4. 4 divided by 4 is 1. 1 times x is x, so x is less than 5 fourths. All right, now what you found is this. So you found, this. Any real number less than 5 fourths is a solution to this inequality right here. Only this one. Okay? Any real number less than 5 fourths is a solution to any real number. So if you pick any real number that's less than this and substitute it, 4x plus 3 is going to be less than 8. Okay? That's what this means. Now let's go to the next one. So you can subtract 3 from both sides. And when you combine like terms, this is 0, you get 4x is greater than a negative 8, and a negative 3 is a negative 11. And then divide both sides by 4. And when you reduce, you get x is greater than negative 11 fourths. What you found here, right here, when you say x is greater than negative 11 fourths, what you found is that any real number greater than negative 11 fourths, and you can also write as a mixed number if you want to. You could say x is greater than 4 into 11 is what? 3, I'm sorry, 2. 2 times 4 is 8. Subtract, you get 3. So negative 2 and 3 fourths. So any real number greater than negative 11 fourths, which means the same thing as negative 2 and 3 fourths, would be a solution to this inequality right here. But what you want to do is you want to find the solution to this absolute value inequality. So that's where the word and comes in. So then to think about that, look at this in terms of a number line. And we're going to put 5 fourths and negative 11 fourths on the number line. So 5 fourths is positive, so it's going to be to the right of negative 11 fourths. All right. Now, so x is less than 5 fourths means this. So you're going to put an open circle. Remember, 5 fourths is not a solution to this right here because there's no equal sign. So you can go to the left because you're shading in any real number that's less than 5 fourths. Over here, x is greater than negative 11 fourths, no equal sign, so it's going to be an open circle going this way. And so remember, and statement is the intersection. So you're going to look, so the solution to this absolute value inequality will be the intersection of these two solutions here to each individual inequality that you wrote. So they overlap here. That's where they overlap. And so then the solution then will be from, I'm going to go rewriting this over. So the solutions then will be from negative 11 fourths all the way to 5 fourths. Open circle. In interval notation, I want you to write this in interval notation now. In interval notation, here's your solution. Interval notation. Since those are open circles, you can use parentheses. So parentheses, negative 11 fourths, comma, all the way to 5 fourths. All right, so that's your solution. So notice what you had to do when you split it apart as an and statement. So basically you're looking for the intersection of those two sets right here. Okay, so in this case it will be between negative 11 fourths and 5 fourths, and then you write your answer in interval notation, noting that I used parentheses because there were no equal signs with the less than or greater than. So that means that 5 fourths and negative 11 fourths would not be solutions. So your solution to the original inequality would be any real number between negative 11 fourths and 5 fourths, meaning this. So if you want to write it as mixed numbers, both of those are improper fractions, so you can write this as mixed numbers. So you could say negative 2 and 3 fourths, comma, and then 5 fourths is 1 and 1 fourth. So any real number on the number line between negative 2 and 3 fourths and 1 and 1 fourth. So there's an infinite number of solutions. Now if you had written it like this in compact form, and you can only do this, you can only write in compact form with a less than. That's the only time you can do that. You cannot write compact form with a greater than absolute value. But you can with less than. So if I do it with less than right here, and let me go ahead and put the problem here. So if you write in compact form, then you had something like this on a previous example, a previous problem that we looked at. So if you were just looking at this simple inequality, then you know to get x by itself, you're going to first of all subtract 3 from both sides. But remember though, they're one part, two parts, three parts. So 3 parts. So you have to subtract 3 from all parts. Then negative 8 and negative 3 is a negative 11, and that negative 11 should look familiar, right? That's this one right here. All right, and then 3 and negative 3 is 0, so you get negative 11 is less than 4x is less than, and then 8 minus 3 is 5, and that 5 is this right here. Okay, and then once you divide both all parts by 4 to get x by itself, you get negative 11 fourths is less than x is less than 5 fourths. And notice how simple this is. This right here is this right here. Okay, negative 1/4 to 5 fourths. I'm sorry, not negative 1/4, negative 11 fourths to 5 fourths. And so therefore your interval solution, your solution in interval notation rather, will be parentheses, no, remember no equal sign, so negative 11 fourths is not a solution. That's negative 11, comma, all the way to 5 fourths. All right, so that's it. So that was number 13. So less than, absolute value less than. If you split it apart, notice how it looks. Less than 8, greater than negative 8, with the word and means intersection. So you do all the work, you look for where the two solutions intersect, and that's the solution to the original problem. Compact form, this is what it looks like. All right, so that's 13. Now 14, this is a greater than. You cannot write greater than in compact form. You cannot do it like this. Mathematically, that's not possible. So you are forced to write it using the word or, just like we did and here. So greater than, and in class and in the lessons, in the videos, we saw why we use the word or. We looked at a simple example and we saw that we saw where the word or came from. So in this case, though, we're going to go straight to the solution process. So the first thing you want to do, just like in the previous one, is you want to get that absolute value expression by itself. So I'm going to go ahead and subtract 3 from both sides. And so I get the absolute value of 7x minus 2, this is 0, is greater than or equal to, and then 9 minus 3 is 6. Okay, so that's where I'm at. So I have the absolute value expression by itself. Once you get the absolute value expression by itself, then that's where you want to split it apart. Remember, this is a greater than. So greater than or greater than or equal to, that's that word or. So that's the idea of that union we talked about. So the union of two sets. Whereas with less than or less than equal to, that was the word and, which was the intersection of two sets. So that's why we intersected here. We looked at the intersection. Or is the union. All right, so then what you're going to do, just like you did in the previous one, you're going to rewrite what you see here without the absolute value bar. So 7x minus 2 is greater than or equal to 6. Or, you have to see the word or, you have to put the word or 7x minus 2 is less than or equal to negative 6. So the same idea that you used here, except one's and, one's are. So remember how we did this. You wrote what you saw, and then on the other one, you said if this was less than 8, you said greater than negative 8. If this is greater than or equal to 6, you said less than or equal to negative 6. Okay? So that's the idea of that distance from 0, the idea of opposites. All right, now you solve each one. So you're going to add 2 to both sides. And so you get 7x, this is 0, is greater than or equal to 6 plus 2 is 8. Then divide both sides by 7. I get x is greater than or equal to 8 sevenths. Okay, now remember, just like in the previous one, what you found here, so any real number greater than or equal to 8 sevenths, which is the same thing as 1 and 1/7. So in any real number greater than or equal to 1 and 1/7 or 8 sevenths is a solution to this linear inequality. Okay, over here, to get x by itself, you're going to add 2 to both sides. And when I do that, I get 7x is less than or equal to negative 6 plus 2 is a negative 4. Divide both sides by 7. and then reduce, I get x is less than or equal to negative 4/7. Now, that's a proper fraction, so I cannot write as a mixed number like I did this. So this is a solution to this inequality. All right? That's what I found. Now remember, this is an or statement. So what that means is this. What that means is this. Any solution to this statement here will be a solution to this because of that or statement. So it says the solutions to this absolute value inequality will be the solutions to this or the solutions to this. That's what that means. So in the previous problem, x is less than 5/4, x is less than 5/4 meant that this was a solution to this linear inequality. But that doesn't mean it's a solution to this because notice not all numbers less than 5/4 was a solution to this. We saw that less than 5/4 it only stopped to negative 11/4. It didn't go all the way to negative infinity. All right, so you have to be careful with the word and or the word or. So what students do then when they look at an or statement and think of the word union, they on a graph they write this information to help them. So you have negative 4/7 here, and you have 1 and 1/7 or 8/7. And let's graph this. So this says that x is greater than or equal to 1 and 1/7. So greater than or equal to, since that's an equal sum, use a closed circle going to the right. So any real number greater than or equal to 8/7 is a solution to this linear inequality. Over here, x is less than or equal to negative 4/7, closed circle because of the equal sign going to the left. So any real number here is a solution to this linear inequality. But that or statement. So the solutions to this absolute value inequality will be consisting of the solutions to this linear inequality, which is this, or the solutions to this linear equality, which is this. So that means then that the solution to this absolute value inequality is this. Anything that's shaded. So look, there are two intervals that are shaded, here and here. So the solutions to this will be any real number here or any real number here. So then in interval notation, you go from left to right. When you write interval notation, always go from left to right, from smallest to largest. So notice that when I wrote interval notation, I put negative 11/4 first because I was smaller than 5/4. So I went from negative 11/4 all the way to 5/4. Always go from smallest to largest. So when I do this, I'm going to say, remember this is pointing towards the idea of that negative infinity, and this is pointing towards positive infinity. So you're going to say, now when you put infinity and negative infinity in parentheses in interval notation, you have to use parentheses. So you're going to say negative infinity with parentheses, comma, negative 4/7 with a bracket. A bracket because of that closed circle. So negative 4/7 is a solution. So I'm going to denote that with a bracket. Here, negative 11/4 and 5/4 were not solutions. See, there was no equal sign. So inside idea of that open circle. So I use parentheses in both cases. Okay, now notice that the solutions are made up of two intervals. So you're going to say union. So hence the idea of that union, right? Union, union. And then you're going to continue from left to right. You're going to start at 8/7 with a bracket because of the closed circle. 8/7 is a solution, comma, all the way to infinity. Okay? And that's the solution. So that's the solution to this. So you have to recognize, though, that with less than, you use the word and. If you write it in compact form, it looks like this. Greater than, you cannot write in compact form. You can only write it as two separate inequalities with the word or between them. You need to show the word or, otherwise you won't get all your points. All right, and that's it. So that's number 14. And then finally, let's look at 15. So 15 is where you're again looking at absolute value equation, but this time there are variables on both sides. So if you notice that, remember the left hand side, you're taking the absolute value of this expression. So the left hand side can be positive because whatever x is, when when you take the absolute value of that, it's never negative, right? So it'll be positive, but it can also be 0, but it's never negative. The right hand side, depending on what x is, can be positive, 0, or negative. So if this is negative, that means that this side's positive, so whatever number that is would not be a solution. So meaning this, when you solve for x, you must check your solutions. Must check solutions. Since there are variables both sides, this does not have absolute value bars, so this side can be negative. This side will never be negative, so you have to check. All right. In the other equation, the absolute value equations, if I can get it real quick, in this one we didn't check. We did not check because this side right here is always positive. That 15 is always a positive number. It's never negative. So I knew that whatever solution I got here would be a solution to the original equation. But here, 2x minus 6 can be negative, and this absolute value of 5x plus 3 will never be negative. It could be positive or 0. All right, so then you're going to have to check. All right, so we're going to do this just like we did the other one. So remember when we did number 12, we broke it apart. We wrote, first of all, we wrote what we saw, right? And then on the other side, we took the opposite of this numerical expression. So first thing I'm going to do is write what we see. So I see 5x plus 3 without the absolute value bars is equal to 2x minus 6. And on the other side, you're going to say 5x plus 3 equals remember right here, 15, the opposite of 15. 2x minus 6, the opposite of 2x minus 6. All right, so that's what you write, the opposite of 2x minus 6. And then you solve each of those linear equations. So I'm going to subtract 2x from both sides. I get 5x minus 2x is 3x plus 3 is equal to, this is 0, minus 6. Subtract 3 from both sides. I get 3x, this is 0, equal a negative 9. Divide both sides by 3. I get x to be negative 3. Negative 9 divided by 3 is negative 3. Okay? Over here, I'm going to go ahead and distribute the negative 1, or take the opposite of each term. I get 5x plus 3 is equal to, the opposite of 2x is a negative 2x. The opposite of a negative 6 is a positive 6. And so I'm going to bring all the variables to one side, all the constants to the other. So I'm going to add 2x to both sides. 5x plus 2x is 7x plus 3 equal, when I combine those two terms, that's 0. It's equal to 6. Subtract 3 from both sides. I get 7x. This is 0. It's equal to 6. Subtract 3 is 3. Divide both sides by 7. I get x to be 3/7. Okay? All right, now you have to check. You have to check your solutions. Okay. Now, someone said that, hey, a negative 3 cannot be a solution because it's negative. Be careful. When you have variables on both sides, it is possible for a negative value here to be a solution to the original. So don't say it is an extraneous solution because it's negative. That is not a correct mathematical statement. All right, so you'll have to check the original and verify that it is a solution or not a solution. So for this one, you're going to check. So let's check x equal negative 3. Always go back to the original equation. Here's the original. The absolute value of 5x plus 3 is equal to 2x minus 6. All right, and then you substitute where we see the variable x, you substitute negative 3. So I get the absolute value of 5 times negative 3 plus 3, and I want to see if that's going to equal 2 times negative 3 minus 6. Well, 5 times negative 3 is a negative 15 plus 3. Negative 15 plus 3 is a negative 12, and the absolute value of a negative 12 is a positive 12. Over here, 2 times negative 6 is a negative 6. A negative 6 and a negative 6 is a negative 12. Notice that those are not the same. All right. Now, I want to mention something. Some of you, when you checked, you said you made a computation error here. let's say. And so let's say you got 11. And then over here you got negative 12, and you said that that was not a solution. You're right, it's not a solution, but your computation error is incorrect because it's always going to be this way. When you get that absolute value by itself, right here, when the absolute value is by itself, it's always going to end up where the if it's not a solution, those two sides are actually opposites of each other. So if this is a 13, this is going to be a negative 13. If this is a if this right here is a negative 17, then this will be a positive 17. All right, you won't have negative 17, 15. So if you do, you have a computation error somewhere. All right, so just keep that in mind. And then so notice they're not the same, right? So that means that x equal negative 3, which is a solution to this linear equation, but it's not a solution to the absolute value equation. So this is extraneous. So we talked about the word extraneous before. That's a false solution. Now let's check 3/7. Again, you must check. All right, so be careful. Don't always say that all negative numbers here is not a solution to an absolute value equation. That's not true. All right, so x equal 3/7. So go back to the original, which is the absolute value for 5x plus 3 equal 2x minus 6. All right, so then where we see the value, the variable x, I'm going to substitute 3/7. So 5 times 3/7 plus 3. I want to see if that's going to equal 2 times 3/7 minus 6. Well, 5 times 3/7, 5 times 3 is 15. So that's going to be 15/7 plus 3. And let's work with that 15/7 plus 3. So 3, so I got to find the least common denominator, which is 7. So 3, so I have 15/7 plus, and then 3 is equivalent to 21/7, because 21 divided by 7 is 3. 15 plus 21 is 36. So that's the absolute value of 36/7, which is 36/7. Okay? So hopefully on this side I get 36/7. 36/7, 36/7. 2 times 3 is 6. So I get 6/7 minus 6, right? Okay. So 6/7 minus 6. The LCD is 7, right? So I get 6/7 minus, and then I want to write an equivalent fraction with 7 as a denominator. So 6 divided by 1 is equivalent to what number divided by 7? So 1 times 7 is 7. 6 times 7 is 42. So 6/7 minus 42/7 is a negative 36/7. Notice this is positive 36/7. This is a negative 36/7. Those are not the same. Those are opposites. So that means is that this is extraneous also. That's an extraneous solution also. So notice both of my proposed solutions, both of the solutions to these two linear equations are not solutions to the original. None of them work. None of them are solutions. So therefore you're going to say your answer, you're going to say solution, in the blank you're going to say no solution. No solution. Okay? All right. Now, there are some problems. So in your test or another worksheet or a quiz, when you're given this, it could be that one's extraneous and the other one is a solution. So that's why it is important that you check both solutions. Okay? All right, so that is it. So that is problems, let's see, 12 through 15. So 12 through 15.